My guest today is Robert Martin. Robert, how are you, sir?
I'm very fine, thank you.
People know you as Uncle Bob. Can I call you Uncle Bob?
Yeah, sure. Go right ahead.
Oh, I don't want to step on any toes.
That's fine.
Okay. You've been talking about a book you were reading that you were
Yes.
admirer of. Let's talk
Yes.
about that.
So the name of this book is The Structure and Interpretation of Computer Programs. It's an old book.
Sounds impressive.
I think it's from the 80s. Written by...
Did they have computers in the 80s?
They did have computers
Okay.
in the 80s. They're not as good as today's,
Right.
but the book is written by two professors from MIT,
Uh-huh.
Abelson and Sussman. I can't remember their first names. And they taught the MIT computer science course.
Right.
And they taught it in a language called Scheme, which is very closely related to Lisp. And the book is their syllabus. It goes step by step by step through their course. So it's a fascinating book. First of all, the book is free. You can download the book on the internet. Just look for Structure and Interpretation of
So it's
Computer
all in public
Programs.
domain these days.
It's all in PDF.
It used to be in the old
Gorgeous.
days you had to go to college to be a computer science. I mean, that was a had
Well,
to.
yeah.
Almost had to.
Yeah, before that you couldn't go to college to be a computer
Right,
scientist because
but I
there
mean,
weren't any
yeah.
computer science
But
courses.
basically, you had to work for a big company that owned a computer, and they wouldn't hire you unless you had an advanced degree.
Yeah.
So,
Yeah,
but,
that's
this
those
is
days.
the start of that, or the middle part of that. I
Yeah,
guess.
the middle part of that, I'd say. So the book is fascinating because the book it moves very fast. It's very unapologetic. It's very technical, and they begin with very simple programs that they just show you on the pages, and they describe what they're doing, and then they go to the next one, and the next one, and the next one. There's probably a series of 20 or 30 programs in there, and they grow and grow in complexity. And each program describes some new and interesting facet of what they're trying to tell you. And it's all done in Scheme, which is very easy to understand. They don't even try and explain the language. You just kind of pick it up as you're reading the book. And then there's this event in the book. It's about page 246 or something like that, where they stop. They've got all this momentum going, and it's fast. And I remember reading the book. I was just throwing the pages. Very exciting.
And then all those speed bump.
Textbook. And then they throw in this speed bump. It's actually a full stop. Stop. And they apologize profusely for what they are about to do.
So it's
and
not an
they
accident.
complain about, this is going to be terrible, but we have to do it. And they introduce their first assignment statement. And I was thunderstruck. And I was reading this book, and I the brakes go on, and I'm kind of like, what? There's been no assignment
So you
statements.
didn't realize as you were looking at this program that
No.
there was no.
It never entered my mind.
assignment to a variable.
Throughout the entire thing. So I had to go back and read all these programs. There's no assignment statements in any of them. They're doing all this work. No assignment statements. And they go on to explain that assignment statements break the whole flow of time. They cause the system to change state from the before the assignment to after. It makes the whole problem much more complicated. They go on for a page apologizing. And then, for about 50 more pages, they demonstrate some programs that take advantage of this ability to change the state of a variable, and they're very interesting and complicated. And they say several times, this is never really ever necessary, but sometimes it's convenient, blah, blah, blah.
Interesting.
And they build up a little bit more momentum, and then they stop again, another full stop, 50 pages in, and they introduce threads. And it's just fascinating to me that they equate the complexity of assignment statements with the complexity of threads.
Right.
They're these two full stops. We've got to
Yeah,
evolve.
thread seems much more complex to me. Probably
You'd think.
because in the 1980s, when I first learned computer programming, assignment statements were the first thing I
Yeah,
learned.
absolutely,
This is
right.
a variable.
Yeah.
This is how you assign values to it.
Yeah, but functional programming is the thing everybody's interested in now, although it was invented in 57 and probably long before that. 'Cause it's predicate
It is, you're right,
calculus
it is the new
and stuff like
hotness.
And it's based on the idea of not using assignment statements, right? In
Because everything
functional
is
programs, you don't change the state of a variable. So, fascinating book, a thrilling read, exciting as hell.
When did you read it?
When did I read it? It must have been about 9 years ago.
9 years ago. What did you change? Did it in any way change your behavior as a computer scientist after
Absolutely.
that?
Yeah,
What did it change about you?
It changed the way I looked at the fundamental structure of programs. It is possible and desirable to write code without assignment statements as much as possible, to not mutate the state of variables. And that forces you to think about software in a very different way.
Mm-hmm. Did you change the way you were coding? Did you stop? Did you assign variables less frequently?
Yes. Yeah, I do that very intentionally now. I assign variables less frequently.
So you are a more functional programmer today than you were 11 years ago.
I try. And then I also try to use languages that are more friendly in a functional environment. So the language I use right now most frequently is Clojure, which is a Lisp-based language that sits on top of the JVM.
How are your programs better now because of that?
So if you do not change the state of a variable, you cannot have concurrent update problems because you're not updating anything. So in a multi-threaded environment or a multi-process environment, you don't run into race conditions. It really comes down to that. It's also it forces you to keep your data in much better order. Right. There will always be times when you have to change the state of the system, but you do so with a tremendous amount of discipline in these languages. You treat the changing of data in the system the way you would treat a transaction on disk.
Okay.
Right. Always protected from threads, always blocked or otherwise protected, always with a lot of ceremony. It's not as simple as saying I equals 2.
Okay, so this is something that I've said in computer science many times, is that computer science, like a lot of parts of life, there's very little dogma. There are guidelines that will help you, like, for example, keep everything immutable, don't change anything. But that doesn't mean never, ever, ever. It means stop and think about it before you break those rules.
Certainly.
Is that an example of this?
Certainly. Yeah. There's places to use discipline. In fact, all of the major paradigms, right, the structured paradigm, the object-oriented paradigm, the functional paradigm, were all discipline imposed upon a more freely used structure first. So structured programming was discipline imposed upon GoTo. And object-oriented programming is discipline imposed upon pointers to functions. He replaces that with polymorphism. And functional programming is discipline imposed upon assignment. It's not that you're saying never do any of these things. It's just we can put some discipline on them and make them safer to use and improve the structure of our programs.
Outstanding. I like it. I'm going to find this book.
Oh, I'm sure you'll enjoy it.
And Interpretation of Computer Programs by, I didn't write the names of the
Abelson and Sussman.
Abelson and Sussman.
And all of their videos are online as well. They videoed their
courses?
Their lectures. So it's fascinating to watch these guys writing Lisp on a blackboard with chalk, right? And all the parentheses at the end.
Yes, that's right.
It's wonderful to see.
Lisp is a very terse language.
It is a terse language.
I've never actually written any Lisp.
Oh, wow, you'll enjoy it.
I've attempted to read it.
Very, very simple.
Excellent. And where can we find more about Robert C. Martin?
You can find more about me at cleancoders.com, which is where I have a whole bunch of videos for sale.
Uncle Bob, thank you so much.
Thank you. I got into this field in high school, really. A group of friends and I were exploring electronics technology and software technology, and we all but dropped out of high school. I mean, we continued to go, but every spare second was in a study hall or some other place where we could gather together and draw circuit diagrams or write little programs. We stayed after school to fiddle with the computer science lab. We went home after school and worked on it. We spent our summers working on it. We were friends wrapped up with a certain technology.